Right, so our project is AVRGlove. Exactly what it stands for, a virtual reality glove. Go on to the next one. Alright, so it is virtual reality glove. The project was for this class. It was hardware and software. So we're able to try to make a replicable VR data glove, which is right here, and we'll kind of get into how much it costs later on. And then we're also working on open source software that we're going to be working on during the summer. And we'll kind of get into more of what we've been working on there. We actually have a new part of that software that we'll show at the end here too. So purpose, we seek to improve replicability of the glove. We wanted to provide an application framework for people to make their own custom gloves. And of course, this can be used for, we use it for a data glove later on as well, but it can be used for any VR cases. We show it in Steam VR games. Of course, we'll have to develop more drivers for other cases, but yeah. So, of course, accessibility for commercial gloves, not very accessible. They're over $1,000 for commercial data gloves. They're also used for specific use cases as well. Our model is about $110, and then of course this Vive tracker, which costs $130, but we are wanting to implement by the end of the summer our own tracker as well.
Yeah, so a little bit about how it works. This is a picture of the glove blown up. We have it here as well. But as Ethan was kind of talking about, the Vive tracker is what we're using to track the hand position. So with the Vive, you've got all your lighthouses, your headset, and then the controllers, and they all use the IR lights. So the Vive tracker does the same thing as the controllers. Demo it. It's got all these little black little circles, and this has all the same little ones, so it's tracking the exact same way. The flex sensors here, these copper strands, they actually measure resistance. So when it's fully extended like this, the resistance is very low, it's 0. So we're just kind of translating that number to our hand model in Steam. And then when you bend it, it gets higher. The max for these is 4095, but we have a little math function that we're running our data through to accurately measure the fingers in Steam VR. Because sometimes when you bend them, it would the resistance would get way too high, way too fast, and your fist would be closed when your hand's actually like this. So we ran a little math algorithm. It kind of corrects for that. And all of this is running on an ESP32, which is contained inside of this little 3D printed box. It's got Bluetooth, so as you can see, we're plugged into USB here, which is kind of limiting. But these computers don't have Bluetooth. But if they did have Bluetooth, we'd be able to stand way out here. Actually, these computers might have Bluetooth. We didn't try that. But yeah, it works with Bluetooth. So as far as our process went, this is kind of a nice little sketch. It was version 0, Proto 0. And the first step was to assemble the hardware. So with the help of Dr. File, we were able to get all of the hardware sponsored by the school, which was very cool. And we were able to kind of put everything together and assemble everything. We were able to use our custom firmware for our dev board to just relay data back to the Steam VR drivers. And there's actually a big hobbyist driver out there called AVRGlove. That's what we used for this kind of iteration. It's really good for working with Steam, but not for anything else. So in the future, when we make our own software, we want to have our own custom application that can work with Steam drivers, that can work with data glove stuff. And we have a video about kind of where that application is at currently that's coming up soon. And as far as future work goes, yeah, so we want to create that application framework. And that application framework, the end goal would be you kind of plug in the glove, and then you launch that framework, and then you configure everything there. It's super user-friendly. And then that application talks to Steam. It talks to whatever data scientific applications you're using. It can talk to really anything that you wanted to configure it to talk to. It'd be very customizable and have multi-sensor support. So right now we're just using flex sensors to track finger curl. We can't do something like this. We can't pick that up. But eventually we'd like to have IR sensors on the fingertips themselves and the hand itself, so we can get rid of the Vive tracker, because this is over half the cost of the glove. So if we can get rid of this, we could get the entire cost of the glove down to probably like $120 just for one glove, which is very good. It's very accessible. And as Ethan was talking about, most conventional use case data gloves are 4 figures or more. So it's kind of crazy. And yeah, so this future work, we want to have a deep learning gesture recognition algorithm. So for our AI final, which was Friday, we did this. So we kind of made one. It's trained on 16 ASL letters right now. And there's a video. There is a video. You want to play it? Should we play it? Sure, let's play it.
So this is kind of another aspect of the framework that we want to implement, the software that we talk about. This is our own AI model, and we want to be able to replicate and use this AI model for different cases. So I believe we were talking about gesture recognition in VR games, and it's something we go over in the class as well. So with this, we'll be able to implement our own gesture recognition. We have a few gestures that are supported by AVRGloves, but of course we want to get rid of using other people's drivers. So we will be able to implement our own gesture recognition, and this is just an example of it. Of course, it's a different project. We're not going to use the same code or anything, but this is just for ASL language or ASL letters.
Yeah, it's really hard to see, but it's outputting the gesture there. This resolution isn't very high, but that's K. So there's a couple that are finicky. L is a little finicky, and then C and O are super similar, so it's kind of difficult for it to distinguish between that. And our AI model is kind of just bare bones right now, especially with only sensor data. But it's doing pretty well for an AI model. See, that's O and it's saying C. It's saying, it'll get there. There it is. And S, I'd say of the 16 signs, 3 of them are finicky, but the rest are actually very good. Yeah, X and Y. Nice. Okay, and then we can actually demo it now in Steam. Should we go to the lab?
Yeah.
Let's go to the lab.
Alright, so this is using the AVRGloves driver to put us into SteamVR. We have functionality with the glove, so let's do this here.
You're missing a vibe tracker.
For real?
Yeah.
That might help.
Yeah. Might need that.
There you go.
Our very secure and innovative vibe tracker mounting mechanism is a 3D printed part and then a super glue elastic band.
You know what I say, if it works, it works.
Exactly.
Alright, and yeah, we didn't check the Bluetooth, so I might be out of range here, but just because I'm using the USB cable, maybe you control it. Yeah, it's hard to put on with. Alright, okay. Alright, so we're just going to focus on the, oh my gosh, let me move out of the way here. So we're just going to focus on the hand here. The lab is very cool because it shows you how much you are pulling each finger. So as you can see here, I can do a peace sign. Let me move back one more. Rock symbol, and then fist. Okay, well, sometimes it has little issues, but there we go. And then we can also interact with objects in space. So any, I can't move very much, but any Steam VR game past 2018, I believe, is when they have the skeletal input, I think they call it. So you're able to play this on different games other than just Steam applications, but anything that uses the Steam VR skeletal hand structure past 2018, you can use it on. You see my hand down there kind of glitching. All right.
Do you want to go to the long bow?
If you want to.
And why not?
And if you can see here, this is what it emulates the valve controller. which allows for it tracks your fingers on top, I believe. So it's emulating that is how we're able to do all this. All right. And then, as you can see, you can interact with it. I don't have a lot of motion here, but you get the idea.
If we were Bluetooth, you'd be able to like walk around and stuff, but obviously we're tethered. But this works with any Steam VR game past 2018, like Ethan was saying. So we were messing around, we were playing like Escape the Backer and stuff like that. It was terrifying, but it was fun.
Alright. So,
Hey, there we go.
yep. So this is our project. So, any questions?
All right, round of applause.